Hello everyone, welcome to Mindspan Education. Last video we looked at the normal random variable. We looked at their PDF, expectation and the variance. Now we might be interested finding the probabilities. We might ask that what will be the probability that this normal random variable, or let's say this standard normal random variable, takes the value less than equals to 3, or might be probability in general that random variable x takes the value less than equals to little x. How we can find this probability? So we have the PDF, right? So we might be interested in finding the probability that standard normal variable, random variable takes the value less than equals to little x. So that would be, so we have to integrate the PDF from minus infinity to the point where up to which we are try to find the probability. So minus infinity to point x till this point x, and what will be the integral PDF? That would be 1 divided by root 2 pi e to the power minus x square divided by 2 dx. Since this x is a standard normal random variable, so the mean would be 0 and the variance would be 1. Right, so that is why we have written this PDF with the mean 0 and variance 1. Now we can proceed and we can find this integral, and once we will have this integral, we will have this probability. But the problem with this integral is that it will not have any kind of closed form expression. What do I mean by closed form expression? So let's say if you have this integral x cube dx, so that integral would be x to the power 4 divided by 4 plus c. So ultimately you are able to write this integral in terms of some combination of some algebraic expression, right? Or there are many integrals which you use the different kinds of method, and ultimately you are able to write these integral in terms of some combination of some basic functions, and those basic functions might be algebraic one, or maybe exponential, or maybe trigonometrical or logarithmic. The problem with this integral is that you will not have the last expression that is in form of the combination of the basic function, right? So what method do we use to find this kind of integral? There are various. Might be you can approximate or find a function like error function that is close to this integral and approximation of this, or might be you can use the numerical method. There are various numerical method which you can use to find this integral, or maybe you can find this for different values of x, and you can put it in a table and you can refer that table whenever you want to have or calculate some probabilities, right? So we will have, so that is why you have already seen that we have this table, that normal distribution table. So we are going to just refer that table and we will be finding the probabilities of various values that random variable can take. So the point to note here is that we will be referring the table. In the examination you might be directly given the values, right? So in short, I will just give you what is this table and what actually this table is giving to you, or what kind of information this table contains, right? So let me first of all bring this table to you in front of you. So this is the standard normal table. So standard normal table, that means it will have the mean 0 and variance that would be 1, right? And if you observe, if I ask you what will be the probability that random variable x and standard normal random variable x takes the value less than equals to 0, right? So less than equals to 0, so that means you are interested in finding the probability of this event. So if this is your normal distribution function, it will have the mean at 0. So you might be interested in finding this probability. So area from minus infinity to 0, right? So anyhow, since this is symmetrical around this 0, that means this probability will be half or 0.5. Let's look at this table if you are able to find how we can use this table. So here it is 0, right? And we are looking at exactly 0. So this is 0 and this is 0. So you see it is 0.5. So basically this table is of the CDF cumulative distribution function. So you can write what is the definition of cumulative distribution function. It is nothing but the probability that random variable x takes the value less than equals to little x. So this is what the cumulative distribution function is, right? The definition of the cumulative distribution function. So let me take the phi for denoting the cumulative distribution function, and it will be function of this little x, right? And this is what the exactly cumulative distribution function is. And the table that is given to you is also a table of the values of these cumulative distribution function. So here you can write the same probability in terms of this cumulative distribution function, that you are trying to find the value of this CDF at little x that is equals to 0. And if you follow the definition of the cumulative distribution function, it is nothing but the probability that random variable x takes the value less than equals to 0, right? So the value that you are seeing is the value of the cumulative distribution function. This table is giving you the value of the CDF, right? Alright, let's try to find few more probabilities. We might ask that what will be the probability that random variable x takes the value less than equals to 1.16. Or if you have to write the same thing in terms of the CDF, you can write the CDF value at 1.16, right? So 1.16 would be somewhere around here. So we want to find the area of this part. So you can easily refer this table to get the area or the probability of this event, right? How you can use this table again? So this is 1, right? So you are going to look at this column. The 1 is here, right? Let me zoom it out. 1 is here, right? And 1.16. So this is 1, and so 1.16, right? So 1.1 is this one, and 0.6. So 0.6 is here. That means you are going to take this value, right? So 0.8770, right? Let's try to find one more probability. So you might be interested in finding the probability that random variable x takes the value less than equals to maybe 2.9. And if you have to write the same probability in terms of the CDF notation, the value of CDF at 2.9. You can again refer this table. So basically this what this table is giving to you. This table is giving the area under PDF up to a certain point, right? Here we have found the area of CDF up to x is equals to 1.16. What will be this? that random variable x takes the value less than equals to 2.9. So look at here. So 2.7, 2.8, 2.9 is here, right? And we need to exactly find at 2.9, so it is 0.9981. Right. So also we might ask this probability that random variable x, what will be the probability that random variable x takes the value that is less than -2, right? And if you observe this table, we do not have anything with the negative value, where random variable is taking some negative value, less than negative value. So what we can do, we can simply use the property to find. So this is the standard normal PDF, right? And we have been asked to find the probability that random variable x is less than -2. That means we are interested in finding this area, right? And this PDF is symmetrical about this point 0. That means the area from -infinity to this point will be same as the area from the point 2 to infinity, right? So so we have to use the same table. So how we can do that? We can simply, what we can do, we can simply find, so what's the total area, what's the total area of this PDF? The total area would be 1, right? So total area minus till this point, so we can write this as 1 minus probability that random variable x takes the value less than equals to 2, right? So 1 is the total area, and this will be the area till here, right? So total area minus this area will give me this area, right? And it is equivalent to saying that due to symmetry these two area will be equal. So we can find this using the table, right? So 2 is here, so it is 0.9773, so this probability will be 1 minus 0.9773, right? And same thing you can write in terms of the PDF notation as well. So this will be nothing but 1 minus the CDF value at 2, and this will be CDF value at -2. That will be equal to 1 minus the CDF value at 2. Alright, and you might have one more question, that this table is of a normal or the standard normal, for the standard normal distribution. What happens if we have the general normal distribution? Let's say if you have this general normal random variable and it has the mean, some mean at 6 and variance 4, right? And now if you are interested in finding the probability such that random variable takes the value greater than 2 and less than equals to 8, right? And we have given this table of the standard normal distribution, right? So how we can use this table to find the probabilities of any general normal random variable? right? So point here is that we just need to make this random variable as a standard random variable, and to do so, whatever the compromise we have to do, we are going to do, right? So once we will have the normal or the standard normal distribution or the standard normal random variable, then we will be using this table to find the probabilities, right? So what is the trick that we can adopt here? So we are interested in finding that random variable takes the value greater than 2 and less than equals to 8, and the mean of this or the expected value of this random variable x is 6, and the variance of this random variable is 4, right? So what we are going to do, we are going to bring the mean to 0 to make the general normal random variable to standard normal random variable. So what we can do, we can easily subtract the mean from this random variable so that it got shifted by this amount, right? And the mean would be now at 0, right? So in order to do that, we are going to also subtract it from to balance it. So we are going to subtract the both this value from here also, right? Now we have to make the variance 1 or the standard deviation 2, sorry, we have to make the variance 1 in order to make this general normal random variable to standardize or the standard normal random variable. So we have already shifted the mean. Now we have to also make the variance 1 or standard deviation 1. So what we are going to do, we are going to scale this to 2. So how much amount we are going to scale, that depends on the variance, sorry, standard deviation. The standard deviation is nothing but the root square root of the variance, right? And we are going to do on the both side, right? Now this random variable, that is x minus 6 divided by 2, will have the mean 0 and the variance 1, right? So what we have done, so this x have some mean, so this is general normal random variable, it has the mean mu, and let's say it has the variance, that is sigma square, right? And what we have done is we have subtracted or shifted the mean divided by, we have scaled the overall the shape of the or the and how we have scaled by the standard deviation or the by the sigma, right? And now this will be normally distributed or will have the standard normal distribution with the mean 0 and the variance 1, right? So we have carried out the same thing on both sides, right? Now we are interested in finding this probability. So this probability will be 6 minus 2, 6 that will be minus 2 random variable. So now this random variable will have the distribution that would be a standard normal distribution with the mean 0 and variance 1, right? Now we can use the table, right, to find this probability. How we can do, we have seen in last video that this probability is nothing but the CDF value at 1 minus the CDF value at -2, right? And what will be the value of CDF at 1? So this is 1, so that is 0.413, 0.8413, right? 8413 minus CDF value at -2. So what we can, how we can write? That would be 1 minus CDF value at 2, right? Just now we have used this thing here, right? So that would be 0.843 minus 1 minus the value of CDF at 2. So this is 2, that is 0.9773, 0.9773, right? So this is the probability that random variable takes the value that is greater than 2 and less than 8. All right. So I think that is all in this video. Next video we will be looking at examples. We will take whatever we have learned so far about the CDF, about few special kind of random variable, that is the exponential and the normal random variable. We will be taking few examples and we will solve them. Thank you so much.